This is Unit 4, Lesson 1, absolute value function. Reciprocal functions is the very last lesson. First 4 is about absolute value. The last one's reciprocal function, which you're probably not going to like, okay, because it's fractions. It's functions in a fraction. So it's definitely a difficult piece, so get ready for that. I'd say it's similar to how we ended with solving radical equations and factoring, remember? And that was kind of harder than factoring. Same type of thing. This unit. But anyways, just in general, guys, I will just kind of speed through this part because I think, does everybody feel comfortable knowing what absolute value means? Kind of? No? Maybe? Yeah. No, I mean, yeah, it is an actual number, but here's the thing. This is what absolute value is used for, okay? I'll just very simple. Absolute value is the distance from 0. So then distance can never be what? Negative. Distance can never be negative. I can never be negative 5 feet from cage. I'm always going to be 5 feet from cage no matter how far I'm circling him, right? So it's a distance from 0 idea. So some people say, oh, so absolute value is always positive. Kind of. In a sense. Yep, in a sense. So use absolute value for that kind of stuff. But see here, so if I'm at negative 6, I'm 6 from 0. If I'm at positive 6, I'm 6 from 0. So then we're talking about distance. And when we do absolute value, that's what happens. Now we're going to talk about how the graph works. And we're focusing on for our standard, okay? We're going to go over a quick little absolute value review. So if you have no idea what absolute value is, we'll do that. But we're going to be talking about the function and what it looks like. Does anybody know what absolute value graph looks like? Anybody ever seen it? It's a V. It's a V. Okay, we'll talk about why it's a V. Okay? It works like a parabola in the sense of left 4, up 6. It moves the same way. Flip if it's negative on the outside. All those things, it works just like we've talked about with parabolas, so that's cool. Okay? So let's just go to these absolute value questions here real quick and understand the differences between them. So absolute value of 3, what's the distance of 3? 3. Absolute value of negative 3? 3. Absolute value of 8, then negative. Ooh, crack there. Okay, absolute value of 8, then negative. Negative 8. That one's negative because the negative's outside the absolute value. The absolute value can't do anything to it. Correct, but it's outside of what we can't have negative. Yep, so that's what you got to watch for. Okay, that's why I said you got to look and see this one too. Look, so what's the absolute value of a negative 8? 8, but it's a negative. Okay, it's just like brackets, right? Just think about brackets. If it's in the brackets, it has to be positive. If it's outside brackets, it can't do anything to it. Similarly, if you're still struggling, think about it this way. No, because absolute value of negative 8 is 8 with a negative. Yeah. So like if it was like this, that's still negative 8. So essentially, if there's a negative out there, the answer is negative every time. But look, think about this, okay? This is what you're paying attention to. Those are different, right? It's the same thing. Inside versus outside. Okay? So this is negative 3 squared. This is negative 3 squared. Right, I just wouldn't touch it, yeah. Mm-hmm. Here, absolute value negative 7. 7 plus 7, 14. One minus 5 is negative 4. Absolute value negative 4, 4. And it's like Parker said, he sees a negative outside. Okay, so that makes that negative. What's the square of 81? Negative 9 inside, so it's a 9, which with a negative on the outside. Well, I mean, this is just so you know what absolute value is. Every time, yeah. Distance to 0. Okay, are we okay with that? I would say relatively simple part. All right. Let's talk about the graph now. So now we're talking about graphing f of x equals absolute value of x. And to do that, we're going to look at the absolute value of x, the graph of x and negative x, okay? So what we're going to do is, it asks me here to graph just x, which is just a line, right? And we're going to graph negative x. It's just a line. And they're going to tell you why you're going to do that, okay, for the second part. All right, so if I graph x, let's go and do x here in blue. So I'm doing g of x is x. That's just, there's up 1 over 1, goes through the origin. There's no up or down. It's just a straight line, just like this. Okay, that's your y equals x line. Okay, and then I'm going to do the negative x, the h of x, which is also a line. It's just a negative slope. It's just going down through the same spot of the origin, but it's just going down. So that's what we have. If we do the line of x and the line of negative x, you're saying, well, why are you doing that? Well, let's look and see why. Consider a function of absolute value of x. We're going to plot some points. Yeah. Oh, stretch it. Okay. We're going to plot some points. So for this one, we don't know what the absolute value of x is. I told you it's a v. I kind of gave it away already, but let's complete the table. So if I plug in a negative 5 in here, what's the absolute value of negative 5? 5. And so then we know it's 4, 3, 2, 1, 0, 1, 2, 3, 4, and I think there's a 5 down there. Maybe not. Forget. So we're going to graph those. We're going to plot those points real quick and just see what we see. So at negative 5, we're at 5. At negative 4, we're at 4. We're at 3. We're at 2, 1, 0. And then we're back up to 1, back up to 2, back up to 3. Ah, so it's a V. Okay. I'll let you guys finish that for a second here. Okay, here's the idea. What are the similarities between these two graphs? Yeah, they both make a V. They have the same top. Okay, this obviously has nothing down below, okay, which we expected because absolute value will never have negatives, so we don't have everything in the negatives. Okay, this one we do have something negatives, but the point is they do have the same top. So with that being said, it says explain the similarities. Just I would say the tops are the same. Okay. Okay, and then I'd say the bottom, the absolute value has no bottom. Whoops. Okay, so it says the graph of the absolute value, y equals absolute value of x contains two straight lines. State the equation of the line in quadrant 1. So looking at your V, guys, in quadrant 1's the top right. What's the equation of that line? Yeah, y equals x. You guys see what I'm saying? So we're asking right here in quadrant 1, this line right here is y equals x. We can see that from the other side, right? And then in quadrant 2, what's the equation of the line? Y equals negative x. And so the concept is that they're trying to sell to you is an absolute value graph is a combination of two lines. And it has to be because it's flipping signs. That's what's happening. So what they're doing is that when we're taking, see, because everything in the first quadrant is always positive, right? So it's the normal y equals x line. But everything in the negative quadrant, we need to flip. And so it flips it to a negative. That's what causes it to be a V. We're going to continue to talk about this, but the concept of a V, it's a combination of two lines, the positive line and the negative line. Okay? Why do we need the negative line? Because I need the negative line to flip it back to positive. So like, for example, over here, like -2, -3, I want to flip that. If I didn't, it'd be down here, which we can't be down on the bottom with the y's being negative. Yeah.
So it's the one that's on the positive side, like positive absolute value line?
Yeah. Yeah. Okay. We can see from number 4, the equation y equals x can be written in two pieces. Okay, so here's the two pieces we can write. When was it y equals x? We said this. It was for x greater than 0, y equaled x. For x less than 0, y equaled negative x. Okay, it actually has the thing down there. I kind of wrote it already. Sorry, I can use the thing they have here. Right here. The just an x here and a negative x here because f of x is y, so f of x equals x, f of x equals negative x. The equal to doesn't matter where it's at, just be with one of them because they both go to 0, so they go to the same spot, but just put it on one of them. It doesn't matter which one. So when you're writing that out later, because I am going to ask you to do things, this is called piecewise notation because this graph has two pieces. It has a positive x piece and a negative x piece. So if I tell you to write a piecewise notation, make sure that you're accounting for one of them to be at 0. Okay, so you want to star that. So it doesn't matter which one, or it doesn't matter where. It can be here or here, the equal to part. Not with both. Okay, it has to be one of them. Just because then you have you're calling one spot two things. Because if you say both graphs are going to 0, even though they land on the same spot, which graph do you want then? Because we want one graph to only cover it. Yeah. It's more for continuous, so it's continuous. Because if you have two graphs with two different points, it's technically not a function then. So we don't want to do that either. Okay. All right. So during the absolute value function, so defining it. So if we define it, the absolute value function can be defined as absolute value of x. They say the squaring a square root, because why do they say squaring a square root? Because then you don't have any negatives, right? So I don't really care for that as much, but this is essentially what we just talked about. If I lost you because of the square root thing, all I tell you is you can kind of forget this for a second. Basically, absolute value has two pieces. That's what you need to know. Okay? It has a positive piece and a negative piece. Absolute value of 3 is just 3. But absolute value of 3 is 3. Absolute value of negative 3 is 3. That's what you need. Right. X is what we're absolute valuing. Yeah. Yeah. So here, now let's look at x minus 3 absolute valued. See what happens here. So we're going to go ahead and do this table. So watch. This is where they're selling to you. Now this is getting a little bit redundant. This is the part where we've already done it, but we're throwing a little twist. We're going to graph the line x minus 3 and the line opposite x minus 3. Okay, so let's just do that first, and then we're going to graph absolute value. Okay, so x minus 3 we should all feel comfortable with. The x minus 3 line is going to be down here. Let's do it in green here. X minus 3, it's going to go like this. There's x minus 3. Okay, so x minus 3 at negative 4 would be negative 7. Negative 6, negative 5, negative 4, negative 3, 2, negative 1, 0, 1, 2. If we do the flip, that's really this. Y equals negative x plus 3, right? Flip, flip. See right here? I just distribute the negative in. And so look what happens now. I'm graphing this one. I'm at plus 3. Oh. Another V. Okay, so if I fill these points in, this would be negative 7, negative 6, negative 5, negative 4, negative 3, 1. Except for it would be, this one would be positive 7, positive 6. Sorry, those are positives. Positive 4, positive 3, positive 2, positive 1, 0, negative 1, negative 2. It's the flip. So you kind of see we have that V idea, right? And so we can go ahead and just kind of cut to the chase. The one we're going to do the absolute value of, we expect to probably be that, the part that's above 0. So let's look and see if it is. So if I put a negative 5 into, so we're doing x minus 3 here. Negative 5 minus 3 is negative 8, so that's 8. Negative 4 minus 3 is negative 7, so that's 7. That's 6, 5, 4, 3, 2, 1, 0, 1, and 2. So this is the V. Oops, missed a dot there. Sorry. I see why I missed a dot. So negative 5 is a little bit higher, 8. There we go. That's the absolute value graph. So the part that's important to understand, guys, from this is that this is the negative piece, this is the positive piece in terms of the combination of two functions. So look at this. This is x minus 3. Where'd the v go? It moved what? 3 to the right, just like our parabolas, right? It still holds that same pattern of opposite of what you see. So it moves right 3. 1, 2, 3. Same exact v otherwise. Okay? However, what you have to understand is this is the line right here. This is the x minus 3. This is negative x plus 3. See how they're completely opposite? It's the combinations of two completely opposite lines to flip the sign. Okay. All right. Yes, the v is always going to be symmetrical. Good question. Yep. Yep. It's just like a parabola in that sense. Yeah, you know, you have a little messed up, but yeah. Okay, so then let's finish up this piecewise piece. Ha, piecewise piece. Okay, so the piecewise piece here, it says x minus 3 if x is greater than or equal to 3, right? At 3 and bigger was the positive piece. At less than 3 was the negative piece. Why are we picking 3? Because that's where it changes direction. That's the 0 there, where that v touches down. Okay? Okay, ask some questions, guys. This is the foundation part of absolute value. Are we all understanding why it moves right 3? Anybody want a clarification on that? It was x minus 3, right? How do you make that 0? 3, which is a positive 3, so we go right 3, just like parabolas. Okay? The two lines are exactly the opposite. So these two lines that connect, here's 3. This is the positive, that's the x plus 3 line. This is the negative x minus 3 line. Or wait, was it x minus 3? Yeah. Sorry. There we go.
So to find like the domain part,
Mm-hmm.
you can kind of look at the function and then you just have to make y 0 and then just kind of find
I wouldn't make y 0.
or no, you can like find
The inside 0, you mean?
yeah.
Yeah. You can go like if I didn't know where this thing touched down, I can make this equal to 0.
Yeah.
Yeah. And then you could say, okay, it touches down at 3. That's the change of direction piece. That's the number, Parker, you're going to have here. That's where it switches from positive to negative. All right, so we're just going to go through these a little bit more here. Explain how the equation of the second piece may be determined from the equation of the first piece by flipping. Okay, by flipping the signs. That's all. It's the opposite. Explain algebraically how, without using a graph, how the domain of each piece can be determined. This is exactly what Parker just asked. You can set that inside equal to 0. So let's say it was 3x minus 2. Then I could say, okay, 3x minus 2 equals 0. Add the 2, divide the 3, just like we do with factoring. What's that? Yeah, so 2/3. So this one I just made up off the top of my head. Touches down. The v changes direction at 2/3. So I know when I go right here at 2/3, okay, so just right here, just right before 2, my v is going to be coming like this. Right, that's where it changes direction. Sure. Okay, so yeah, so I just put set the inside equal to 0. There's only one hang up, and I think we talk about that next class. When it's a negative 2x plus 3, things get a little bit different, but we'll talk about that later. Any questions? Okay, it's not too bad. Okay, now let's just go ahead and summarize this right here. Summary. So you should have gained from the first 20 minutes we were talking there. Every absolute value can be defined in two pieces. They have to have two pieces because there's a spot where it switches the sign. It has to be because at some point that value is going to be the negatives, which it flips it back to the positives for you. The absolute value of a quantity will always be the same quantity if the quantity is positive and the opposite quantity if the quantity is negative. Okay, so that's what I just said. It's always going to flip it back to positive. Writing absolute value function in piecewise form is an integral part of determining the solution. Okay, so let's piecewise. If you have been snoozing and don't know what piecewise is, let's try that again. See, this is what I was talking about. 3x plus 2. I said that one off the top of my head. That means I've been teaching this class too long. Because I know it's coming. I don't know how that happens. But it does. I do that like all the time. I'll just make up one that, oh, I'll make this one up. Oh, that's actually coming up next one. Yeah, but I mean 3x and 2, right? Weird. Okay, so right, there's a piecewise function. So you want to go 3x plus 2 equals 0. Okay, minus 2, divide 3. So it's negative 2/3. So that means when x is bigger than negative 2/3, and when x is less than 2/3, it's going to be 3x plus 2 for the positive, negative 3x minus 2 for the negative. So let's explain what we did. First thing we did here is we set the inside equal to 0 to figure out where the v is touching down. The v is touching down at negative 2/3, so right about here. And it's doing this. So we know that after negative 2/3, after greater than or equal to, it's the positive piece, Before the negative 2/3, it's the negative piece. So less than 2/3, opposite, the negative piece. Go ahead. So,
Now would you just plug in a number into x?
you could, but that's all they wanted. I'm done.
But like, if you wanted to find different points
Yes.
on the line, you
Yep.
just plug them in.
Yep, always can do that. This should be negative 2/3. Yep, sorry, thank you. Yep, sorry, my bad. Less than negative 2/3. It's the same number both times. Okay, now B is going to be confusing. I'm a pause the video. Let's take a breath. Pay attention to this one. Okay, so the tricky part with part B here, the last part of this lesson, is that see how that's a positive x? So everything we've dealt with so far started with a positive slope. This one starts with a negative slope. Right, so this is actually a downward piece right now. 4 minus x is downward, right? If we think about, let's think about 4 minus x. 4 minus x is here. It's going down 1 over 1. It's going like that. So the one they give me is the downward piece. That's what we have to understand. Okay, so let's just stay the same rules. I'm going to show you something that's a little bit easier, actually. We want 4 minus x. It's an absolute value, right? We could have done this one. I probably should have done the first one. We always want the absolute value to kick out a what? A positive. How would I write that as an inequality? Greater than or equal to 0, right? I always want 4 minus x to be greater than or equal to 0. So what you do is you say, okay, I'm going to solve for x now. And let's see if you remember. What do you do when you divide by a negative with an inequality? You flip the sign. That's my first piece. X less than 4. Okay? So what that is, it's 4 minus x for x less than or equal to 4. So look at this. This is how this makes sense. Before, the negative piece was the less than, right? But our given piece is a negative slope, so it's my less than piece. Let me say that one more time. Down here, that negative slope was less than, right? We are given a negative slope, so see, it ends up being less than again. Because this line right here, here's 4. This line right here, that's the original. But that original is less than 4, so that's what we just got. This is the first piece. 4 minus x happens when x is less than or equal to 4. So then what's the other piece? Negative 4 plus x for x greater than 4. And you can do that.
So you determine which one's greater by
Well, actually, just simply, Parker, just taking what's inside, saying greater or equal to 0, and solving will get you where you want to go. Just solve that. And remember, you flip the inequality when you divide by a negative. This will take care of it for you. That's what we did. We essentially had to flip it. So now, if you don't like that I just wrote this out any work, you can still do this too. You can go up here and go negative 4 plus x greater than or equal to 0. So you just add 4, yeah? See, that's right here. Sorry, not equal to. We don't. This one we won't do equal to. Remember I said one of them. But that's it. Okay? All right, so let's pause the video. I'll do one more example with you guys here. Let's pause the video, though. We'll stop it here for the video.